Hello everyone and welcome to AlgoMesh Parametrics, which is our flagship product for the moment. And if you're wondering how to install it, well, it's really simple. So you go to the asset browser and go create, import assets. You simply grab the zip file, which you downloaded, hit OK a couple of times until the system does its magic, and then new AlgoMesh category will be created and the plugins will be added inside. So let me show you how that looks. Maybe we can scale this down. So it's 25 very elaborate parametric objects. Many of them exhibit duality in a sense that they can be either a mesh or a spline. So allow me to demonstrate some of those for you. Let's just briefly create a nodes mesh will work because I want to access this node graph, because all of these parametrics, let's go back to the category, actually work inside the node graph itself. So it can be used as a node, which is pretty advanced to use. So let's just connect this to prove our point. As you can see, the object is generated. Or, which will most likely be the preferred use for most people, is simply creating an object which is sitting in the object manager. Now this is quite simple, but you will immediately see that these objects are fantastic. Of course, I will show you just a handful because showing all of them would really take a considerable amount of time. So let's maybe start with the classic brick wall, and let's give it the nice AlgoMesh-like texture because we can and because we like doing that, right? So maybe we can even rotate this so it's a little bit nicer to see in the viewport. What it does, well, it generates a brick wall and it has a plethora of parameters, starting from the overall width, with the overall height, which are pretty simple to understand, with the fill parameter of which defines how you fill that surface. You can change the randomness with the seed, change the brick width, height, so in terms of what can be minimum or what can be maximum, brick height, brick depth, so you're offsetting the solid width, so I can see this in action here. So brick depth, and there is of course that randomness, so some bricks are protruding, some are inwards, uniformity of the whole constellation, even have sort of a larger gap in between them. Now we are coming here to the actual amount of bricks that you want to fill. And you can change the seed and obviously do a lot of things. This grout is actually just a backplate for the whole brick generator. So wonderful stuff. It works out of the box. It's completely parametric. And of course, if you hit C, polygon selection of bricks and a fully editable polygon object. So very useful thing. Let's maybe now switch to something a little bit more abstract. So DNA spiral, and not just any spiral, it's absolutely amazing how many parameters it has. So you can either generate a mesh or a spline, that's the duality. Where it starts, where it ends, does it taper or does it twist, and how many of those twists? And then the actual geometry of the spiral. So how do you define that? So there is the bias and arm height offset. So you see, you can offset each and every arm, and phase offset, which I turns here to be a little bit bigger. Now we have bonds, which are the connections to add, so we can define the spacing between them. We can define the radius of the bond itself, so it can be larger, it can be smaller, and absolutely fantastic stuff. The bond end, so you can go without them completely, and the bond length, it doesn't have to be full length. So very, very nice, very customizable, and very useful, especially for medical visualizations and similar stuff. So twists, actually, one of the main parameters. You can control how many times it will twist in the same distance, right? And it's all parametric. And of course, if you hit C, you'll convert it to a polygon mesh. Wonderful, wonderful stuff. What is also really great about these parametrics is that they can be used way beyond what their official name would imply. So let me show you something. Maybe we could use let's go with a spiral. So a simple spiral, logarithmic spiral, it can be a mesh or it can be a spline. Let's just also give it a nice material like this. So it has again a wealth of parameters, so it can have multiple arms here. So coming out from a single origin, you can have various turns, start, and of course you can taper it, you can twist it, you can change the spiral geometry, you can do vertical rises and create things like this. So it goes well beyond its initial name. So very, very, very cool stuff. Let's maybe try one or two more. So here are some things which are otherwise not available in Sina 4D by default. And those are recursion-based objects, such as this, let's try this Menger sponge. Let's also give it a material. This is very, very, very cool object. So let's select it here, and it doesn't have that many options because it's mathematically constrained. However, let's try something. So this object creates smaller and smaller constellation of cubes in this sponge pattern as the iteration value goes up. So I hope you can see that. One cube, then cube for each point, then another cube for each cube's point, and so on and so forth. You can change the cube size. Obviously, we'll change the whole constellation. And it has interesting parameters such as spacing, so it creates sort of small spacing in between, which can be random, right? And then you change the random strength, so it's all very random. And this fill amount basically has an effect of filling the object. So in case of changing the mode, well, it would randomly appear and disappear, or you can have it sort of from one way to another. Either way, very, very cool mathematical curiosity. Well, here we have level 5, and it's quite detailed and very, very cool. So still workable, still performant, and you can sort of create those sci-fi related appearances, and very cool for motion graphics indeed. Let's try one more, maybe something that is usable inside of architectural environment, so maybe a pillow. Also give it a material. I can zoom in a little bit. So in this case, you're actually displacing, and you can have an indentation object. I can actually show you that. So let's drop this null inside. So wherever the null is, well, that's the indentation area. So you can either have it or we don't need to have it. So if it is clear, then it will use the default one, which is local to the center of the pillow. So let's maybe remove this. So what is really fun is there is a width, height, and there is a thickness. So it can be thicker or really thin. And of course, there is a flattened parameters that sort of deflates the whole constellation. So very, very useful, especially to create pillows quickly. Now there is this displacement which adds details. Maybe we can remove this metallic. Think it will look maybe even better. So now you can reduce the strength, change the overall appearance, and simply change how that overall noise looks like. So very, very cool stuff. and can change the radius and create sort of a different pillow each and every time. Of course, again, if you want to convert it and use it as a polygon object, you press C and then you save the object with the UV map. And maybe for the end, we will try this, maybe Snail, so sort of nature-like thing, and this one is really elaborate. So Snail, and you will see that some of the primitives or the parametrics have the thickness option, so it can have a thickness on its own. Let's give it some material. These are all the thickness-related tags you'll receive. And of course, you can really play with this all the way as you see fit. There are various parameters here, so size, which are named with letters. So you can do various offsets, horns, and change multiple things and shape this. So you can create very, 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 very cool stuff. So you have a taper parameter of this and that, number of coils, and it really goes into endless possibilities in terms of what you can actually create. So really, really cool stuff. You can create sort of horns and whatnot with this and actually enjoy the wonderful parametric nature of this object. Maybe one of the last, which was actually a request, that it has to be in the parametric spec, although it's a little bit unusual. And that one was very difficult to do, and it's a hard primitive. So, and maybe we could even, let's change this to, we could maybe use a color here, which would represent the heart a little bit better. So maybe something like this, a little bit warmer on the warmer side. So let's rotate it. We'll finish really in a sort of a good mood because we are having a nice parametric heart at our hands. Use this. So a parametric heart, of course, you change the definition here. You have width, you have height, you have volume, so it can have a little bit more volume, lobe size. So a nice parameter for that, tightness, which controls how tight the heart looks, so it can be tight or even more relaxed. There is a cleft control, so top cleft, so this little thing inside, how it is defined. Then you have the bottom point, which can be sort of more pronounced. Then you have the taper point, so all really contributing to the final shape. And the overall cleft strength, you can have sort of a saggy heart as well, if it makes sense, or really, really strong elongated heart. The iterations simply defines how nicely the surface is calculated. So more iterations and more smoothing produces a really nice, smooth heart. We have this start end, obviously, if we can lower the iterations here. And what is interesting, we also provided this thickness parameter. That means if you open like this, so you can create various motion graphic stuff, you can actually control the thickness inside. Very, very cool stuff, very difficult to do, and I don't think it is available anywhere else. With a loving heart, we will say goodbye. Hopefully you will grab our plugin. We also have a lot of other plugins, including free ones, so make sure you visit the AlgoMesh Gumroad page. The link is in the description. Until the next time, have fun.